Anyway, cool. Thanks for having me. So yeah, like they said, my name is Mark. I work for Neo4j in the developer relations team in London, and I'm going to present to you something we call the grand stack. So I'm going to work backwards from where we're going to get to at the end of the talk. So we're going to show like some of the steps to build a little JavaScript application using this stack. And so this is what it looks like by the end. So you can see is what it roughly is, and we have a code sandbox URL there. I can share the slides with the organizer afterwards, so you don't necessarily need to take a picture of all of them. So the idea is that we're going to build a little movie recommendation application. So we'll be able to search for movies, and then we'll be able to come back with a listing of the movies, as you can see on the screen now. And we'll get a list of the genres that they're in and some other similar ones to those movies. So we're going to end up with some components in React. So you can kind of see there's three different ones here. So we're going to have a search component, we're going to have movie details, and then we're going to have some recommendations. If you want to have a look at the code of how to build this and the steps, you can take a look at this repository. So if you do bit.ly grand stack, then you can find that, and it will take you, if you want to follow it along afterwards. That's the best place to go. But I guess we'll start from what is this acronym in the first place. So this is the stack of tools that we're using in this demo. So we've got 4 of them. So I imagine at least probably 3 of them you may well be familiar with, given we're in a JavaScript meetup. So we've got GraphQL, we've got React, we've got Apollo, and then we've got Neo4j database. Sometimes people get confused about where the D comes from, so just so that you don't get confused, the D is for database. So we've got, that's the acronym, and the idea is that you can build applications using all 4 of these things, and hopefully it should be easier than trying to cobble something together without these components. So I'll just do a quick introduction to each of them in case you've not used them before. So we'll start with the G. So we've got GraphQL. So this is the tool created by Facebook. It's probably 3 or 4 years old now. So it's invented there, but the adoption is a lot more than just people at Facebook. This is the definition from the GraphQL website. Sometimes the name is obviously not the greatest name ever, so people often get confused and think it's a query language for graph databases, which takes you off in the sort of wrong direction. So this is the definition that they give. So they say it's a query language for your API and a server-side runtime for executing queries by using a type system you define for your data. So that's a cool sentence, but what exactly does it mean? So if we go into the main bits of it, so the first bit is it's a query language for your API, and sometimes people have suggested that this is a competitor or a replacement for REST APIs. So you can see on the bottom left-hand side of the screen, there was a Medium article written by somebody, I think it was in 2015 even, referencing their own tweet, talking about it as a potential replacement for that. And a lot of the things that GraphQL offers you address the perceived weaknesses of what you get in REST APIs. So that's the first bit, is that we're kind of that up the stack. So we're sort of at the service layer tool. So we're potentially replacing like lots of REST API calls or service calls with a single call to a GraphQL API. The second thing is we get this quite nice runtime for executing our query. So we send in a GraphQL query, and we get back some JSON response. This particular example that we see on the bottom of the screen is actually from GitHub's API, version 4. So they introduced GraphQL in v4, and in some of the previous versions, they've been delegating to the GraphQL API from a REST API. So they've actually been using it for quite a while. And the query here, I think you can probably see it, is we're saying I want to go and find some repositories with a certain search term, and the cursor is basically their way of paginating through results. So you can say, hey, I'm going to start from this particular place. And then the thing which differs from a REST API call would be there you say, okay, I want to get repositories, and you might pass in your search term, and it'll just give you everything associated with repositories. Whereas here, you can indicate specifically which bits of information do you want to get back. So you can say here, I'm saying I want to get some page info, so I know what the next page is and I know the next cursor. But then I'm zooming in and saying I want to get the database ID, I want to get the name of the repository, the URL, the last push that date, and then a few other fields which are off the screen. And then when I get it back, it always comes under the data top level item, and then I get only the fields that I asked for coming back. So that's the server-side runtime, and this is a tool called GraphQL, if you want to Google for that afterwards. The final thing is that we need to define a type system when we're using it. And this is an example type system on here. So it's in its own custom language for defining this type system, but in this one we're defining 3 things. So we've got a character, a planet, and a species. And then you define key values, kind of saying like what is in that particular type. So here we're saying a character has a name, and that's just a primitive, so that's just a string. But it also then has an array, can have an array of other characters who are the friends. So that's kind of a self-referential type. But then we have a home world, which links over to this type here. And we have a species, which takes us over to here. And again, a species has an origin, which is a planet. And then that goes back into the middle. And so you need to define this at the beginning. And from this, it will generate your schema, which you can then write your queries against that schema. So for example, on this one, we'd be able to search for characters or planets or species. And then once you've searched, for example, character, you could indicate which fields did you want to come back. You could say, okay, I want to get back the name, then I want to get back my friends, and for my friends, I want to get back their name, and I want to know what their home world is. And you can kind of keep going down this tree of the data structure. This is what a zoomed-in example query looks like. So this is, again, this is a GraphQL API against the, I don't know whether any of you have seen, every summer Yelp have what they call the Yelp Dataset Challenge, where they release a portion of their data. And so they have data around businesses, and then they indicate the category of the business. They have user reviews. They release some of the users. And so my colleague Will created a GraphQL API on top of this data set, and so this query is an example of querying the the Yelp data set to find a specific business. So they have an ID for the business. They also have a name, so you could search by name if you wanted to. So we say I want to get the business with that ID, and then specifically I want the name, address, city, and so on. And then some of the types are a bit more complicated. So you can see for categories, we've got an array of things, and we just say, actually, I just want the name. And maybe there was an ID on the category, but we don't care about getting that back. We just want the name. And then if we imagine that as a graph, so that the documentation of GraphQL talks a lot about kind of structuring the data. So we could imagine that we've got a business, and it sort of breaks down into various components. We've got a name, we've got some categories, we've got a city, and we've got a state. And the only one that then has another layer below that is the categories, which has a name. All the other things are strings. And this is what a response would look like. So again, you see we've got our data on the top level. And then since we said I want to get businesses, we get our business here. And then we get name, address, city, state, postal code, and so on. So that's our intro to GraphQL. So what are people using this with? So there's an ecosystem around this. And there are lots of front-end frameworks. So when we were researching this, we saw people doing stuff with GraphQL, with Preact, with React, with Vue.js, with Angular. React is probably the most popular one of these in terms of integration and probably just general usage. So what is this? I guess this one's probably the most familiar, so I expect you know more about this than me. The stuff I've done is around building web-based components with it, but you can also do stuff on a mobile phone as well. And the selling point is that we're able to build components that are reusable, and we can go and use them in different parts of our application. And we'll have a look at how to do that in the sample app. We then need to figure out how are we going to connect our GraphQL server back to our React front end. And here we end up with what we call a GraphQL client. You could think of these, the way I think of it is it's like a glorified, at the simplest level, the client is a very, very simple HTTP client, sending some requests, getting back some responses. And the GraphQL clients are adding like caching and more clever stuff around the queries than the HTTP client would do on its own. That Facebook have a client, but the one that seems to be used more by the ecosystem is the Apollo client. So that's the one that we're gonna look at. So I'll just do a bit of an intro on that as well. So this is how they position Apollo. So suggest it's a set of tools to make it easier to work with GraphQL. And it splits into two components. So there's some things that make life easier on the client side, and there are some that make it easier for mocking and creating schemas on the server side. And there are two tools that come here, and the one that we're going to be mostly using is the Apollo client. So we're going to stick on the client side, and this has very nice React integration with any GraphQL server library that you're using. But if you were wanting to mock out stuff in your GraphQL server, you could use the GraphQL tools package instead, or as well. And finally, we've got Neo4j. So I'm guessing this is probably the most alien part of the stack for you. So this is the one that I'm the most familiar with, though. So in case you haven't used it before, this is a graph database. So it's a native graph database. What that means is that everything is, that it's not like a layer for querying on top of another database. So for example, on top of MySQL or on top of Postgres. It did used to be, first version was on top of Postgres, but now it's kind of custom written all the way down. And the idea here is that where GraphQL talks a lot about everything being a graph in Neo4j, the database, the data that goes in the database is modeled as a graph. The way it's stored is as a graph. You can then query it as a graph. And we have a query language that goes with it. So it's if you want to Google it, it's called OpenCipher. So it was originated on Neo4j, but there are now several other data processing systems that use it as well. And the most recent one we've been integrating it with is Spark, so that you can run Cypher on your Spark data. And there are client drivers in lots of languages, and the one we're going to be using here is obviously the JavaScript driver. And so the logic of why we started trying to build this is that the GraphQL documentation talks a lot about thinking in graphs, and they say phrases like, it's graphs all the way down, your business domain is a graph. And this is exactly the same terminology that we see people talking about when they start using Neo4j. So very commonly what you will hear Neo4j users after using it for a little bit is they just say, I see graphs everywhere, everything seems to be a graph. Once you start thinking about things with that data model, I suppose. And so we thought, this seems to be like these two communities are thinking about problems in exactly the same way. Okay, so just to go back, so we've got our ground stack, so we've done a bit of an intro to all of those things now. So now we're just going to have a look at how they all glue together. So this is what we're going to aim to get towards. So we're going to, if we start at number 1, we're going to have our Apollo client. It's going to send a GraphQL query to a GraphQL server. And we're going to have that GraphQL server is then going to convert that into a Cypher query. We'll go into Cypher in a bit more detail. So that's at step 2 down here. The response will then come back, and it will be bound by the Apollo client back to our React front end. So that's where we're going to. That's the workflow of what's going to happen. So it's not super complicated. I don't think there's only really 4 steps to it. Now, kind of based with the idea that we've got to define a type system, this tends to be the workflow for building GraphQL-based applications. So you start off with your schema. So for example, we had our species and characters schema. So we need to define that first. That will then come up with a type system, and it will basically set up a bunch of scaffolding for us. We'll then build our UI and backend, and we can choose to mock out a lot of that if we use the GraphQL tools package, for example. And then we can finally connect it all together in production. Right, so step 1, how do we connect GraphQL with Neo4j? Right, so as we said, we've got to create a schema. So we're going to look at how we would do this manually to start with, and then we'll build towards how we do it in a more automated way. So what we've got here is, so when you install Neo4j, that we have some built-in guides in what we call the Neo4j browser. It's like a local development tool. And one of the commands you can run is :play movies, and it will load a subset of the IMDb dataset for you. So we are kind of cheating a bit because we know what data we want, and so we're going to reverse engineer what the schema is for that. And this is what it looks like. So we've got a movie. It then has a movie ID, a title, a year, a plot, a poster. We've got some genres as well. And then in this case, we're just going to allow you to do one query against it. So you can only look up movies by title. And you have to pass in the substring, so what movie are you looking for, and indicate how many results do you want to return, and where do you want to start. Like, do you want to skip any records from the beginning? And it will give you back an array of movies, which is this type up here. And the simplest thing we can do is we can write a custom resolver to do this. So I'll just show you a quick example of what it looks like. So I've got that over here. So if I zoom it in a bit, hang on a sec, see if we can do it. Maybe a bit. So this is what it looks like. So we have on our left-hand side, we've got our movies by title, and we're saying I want to get rivers run through. Maybe we can change this. We'll make it a bit more of a search for the matrix instead. So we searched for the matrix, and we said I want to get the movie ID, the title, the year, and the plot. On here, you get autocomplete, so we could say I want to get some genres. Maybe I just, so we could do it like that. Let's see. So we get back the genre, so that's an array of strings in this case. I want to see if I can go into something. Yeah, so we can also do similar movies. So if I do, so let's say I want to get the first 3 similar movies to the matrix. And so then I can get, so you can see I can go and get the title for those. And I can get, what else should we get? We could get the title, we could get the year. So that's going to get me 3, the movies with the title, the matrix, and then it's going to get some similar movies to that as well. So this is the sort of thing that you can do. So if I make that a bit bigger, you can see what it's doing. So we're saying, okay, I've got the matrix in position 1, it's thriller, sci-fi, action, and then we've then gone and got some similar movies. In this case, it's claiming Star Wars and Jurassic Park are similar, which I guess not entirely sure what exact similarity we're doing. I think we've got a custom resolver, which we'll see in the next slide, which does this. If we scroll over to the right, in case you've not used this tool before, you can do a quick exploration of the schema. So if we click on here, this is these are the query types we have available to us. So we've got movies by title, and it's going to give us back an array of movies. And if we click on there, you can see what exact fields do you have access to. So this is a custom written one. So we've mapped exactly GraphQL query to Cypher query. So that's a simple way of doing it. I'll just show you what the resolver looks like. So if you've done any GraphQL stuff, this is not going to be all that mind-blowing, I don't think. But the idea is that we're defining manually what is our GraphQL, what can we query on this GraphQL server. And we're saying here, okay, I've got a function called movies by title. We take in some arguments. We're then building, this code here is all around the Neo4j driver. So you create a session, and we can execute queries inside a session. So that's what this second line is doing. So I'm just saying, and this is the Cypher query language. So we're mapping GraphQL to Cypher. The way this query language works is we're saying I want to match. So match is the keyword that we use when we want to say I want to find. We say I want to match a pattern. I usually want to go and find something. In this case, it's a very simple pattern. So we're just saying I want to go and find what we call a node, so i.e. a record, that has a label movie. So I suppose movie would be similar to a type in GraphQL. So saying go and find me any nodes that are of the type movie, where the title property contains a substring. So substring in this case is a parameter that we passed in from the GraphQL function. And then we're saying I want to return it and limit it based on what the first parameter said. And then we return it, and we're just doing a bit of mapping so that we map it back into the format that GraphQL is expecting. And so that's it. So that works okay, but if we then decided, okay, I want to search movies by something else, we've got to go and write another one. If I decided, okay, actually I want to search people who are in movies, I've got to go and write another one. And so you can kind of see this is sort of what a bit quite frustrating if we were trying to build something out like this. And this is an example of what it would look like if we did. We wrote like a whole GraphQL server with custom resolvers. So we've got movies by title at the top. We're allowing you to also search and so it actually ends up having to combine multiple queries together. So if you just say, I want the movie by the title, and I just want the movie bits of the schema, that's one query. If you then say, actually, I want you to go and get me the genres, that's another query. If you say, I want to get the similar, if you ask for the similar part of the schema, it goes and does another one. So we get 3 queries, when actually we could probably do the whole thing in one query. So that's what we're going to have a look at next. So this is how it looks at the moment. So we're writing, so the bit which is where we're having to do a lot of work is in part 2 up here where my cursor is. So we have to write, every time we come up with a new thing, we've got to write a new resolver function to do it. And it's not particularly interesting code either. We're just mapping from one thing to the other. And it seems like it could probably be automated. So like I say, this example is showing how we would do it with Neo4j, but it's pretty much exactly the same. If you have a look at any other back-end database or service, without a tool doing any mapping, you would have to be writing the mapping stuff yourself. I don't know whether this translates to Greek. It doesn't translate to Israel, but this is a popular meme in the US and the UK. So it kind of translates to Greece. Yeah, so basically, it's very boring code to write. So we were exploring whether or not we can auto-translate GraphQL to Cypher. So the languages are quite similar because they're both, GraphQL is kind of based on traversing trees, which are a subset of graphs, and Neo4j is based on traversing graphs. So we thought, can we combine these 2 query languages together so that you can have quite a nice experience between the 2 tools? So we built 2 extensions to try and, two libraries to try and help people do this. Attempt 1 was on the left-hand side. So this is a tool called Neo4j GraphQL. And what we did here was that we made it so the Neo4j server allows you to deploy extensions to it, so you can kind of add a custom REST endpoint. And so we added a custom GraphQL endpoint where you could send your GraphQL queries there and get responses back and the GraphQL to Cypher translation was happening directly on the Neo4j server. We also made it so that you could expose a couple of what we call procedures, so you can actually execute procedures from inside Cypher. So from inside Cypher, you could execute GraphQL and get back Cypher data types. And that's okay for non-JavaScript land, but the feedback we got was that's not really the way that people do stuff when they're building their GraphQL stacks. That it's better that the GraphQL server is a different layer of the application rather than being coupled to the database. So that one's not so good. But what we have instead is this NPM library on the right-hand side called Neo4j GraphQL.js. And this one, instead of pushing it onto the server, it is actually using a parsing library, one of the JavaScript parsing libraries. On the one on the left, we were using a Java GraphQL parsing library and then converting that into Cypher. Now we're using a JavaScript GraphQL parsing library and converting that into Cypher. And so this time the Cypher translation is done one layer down, so it's done in the GraphQL server level, and then we post the Cypher query to the Neo4j endpoint. And so this kind of covers some of the things that I mentioned in the previous section. So the first thing is we can do all this in one query. So rather than having to do the 3 queries to get the genres, the parts of the movie, and the similar movies, we can do the whole thing in one query. And the other thing is we've added in the ability that if there's something you can't do in GraphQL, you can add like an annotation and say, hey, I want to run a Cypher query here and have this return some custom results for me. So that leads us to movie schema number 2. So we've extended it a bit. So this is what it looks like when we're using the extension. So I'll explain the bits that are different. Hopefully you can see this at the back. So the first bit is the same. So we've got our type movie up the top. Where it gets different is when we come down to where my cursor is now, the similar line. So before we had a separate resolver that was handling the similar. This time we're using a Cypher custom resolution here, and we pass in a statement, and it's a really simple one here. It's just saying it passes in whatever the current value, so i.e. the current movie is, gets passed in as the parameter this. So we're saying, okay, I've got the this, and from this movie, go and find me, it's a very simple similarity query, find me all the other movies that have the same genre as me. That's what the similarity query is doing. And then we've got a degree query down here, which will tell us how many actors are in my movie. So that's what this one's doing here. So it's just finding all the relationships coming into me, which in this case are, so it would be actually actors, it would be directors as well. And then the last thing is, on the actors row line here, we've made an at relation annotation, and this is copied from what GraphQL, or I guess they're now called Prisma. So this is what they were doing when they were trying to create relationships. So in Neo4j, relationships have a name. Rather than being a join table, we actually name the relationship between each record or each node. And so, for example, we would say an actor acted in a movie. That would be what the data looks like inside Neo4j. And so, from the perspective of the movie, if we're trying to find who acted in it, we need to follow the acted in relationship coming in towards me. So we call that like an incoming relationship. So if we were doing it the other way around, if we were saying show me from the actor what movies they acted in, we would say that's an outgoing relationship from the actor. So that's the schema. And this is what the extension does. So it takes the GraphQL query, it takes the type here, and it makes it into a label. So we say, here, I want to go and find the movies. The title kind of maps exactly to a property, so the title goes over there. We actually introduced this syntax here because we really liked the way stuff was done in GraphQL. So what this is saying is, oh, sorry, I should go back. Return me the movie node, or return me the matching movie nodes, but I only want you to get these fields. So title, year, and IMDb rating, and there are other fields, but we're saying I don't care about them. And so we actually introduced this syntax into Cypher before we even had any mapping from GraphQL to Cypher, just because it's a really nice way of writing queries without having to get back all this potentially information that you're not interested in. And then finally, we're skipping nothing, but we've got that in there as a placeholder. So that's what the library does for you, and this is a very simple example, but as you build up more complicated ones, it's still doing effectively the same thing. I got a launch pad so you can see what it does. This one doesn't seem to be executing at the moment from when I tried it before, but I'll just zoom it in so you can see what the code looks like. So at the top, we import the Neo4j GraphQL JS library up here. We define our type system down here. So this is the same as what we had on the previous slide. Notice we've got the Neo4j driver as well. And then the code to do the resolution is now tremendously complicated. It is just that. And that will automatically map all your the GraphQL schema or GraphQL queries to the equivalent Cypher query and get back the results. If you wanted to then add some other resolvers in here, like say you were using Neo4j for your movie recommendations, but you were using another service or another backend for something else, you could go and add that in as another resolver. So there's no reason you couldn't do that. And then the rest of this code is just wiring up the driver. And that's pretty much it. So that instead of having to write all the resolvers manually, you can just use this piece of code. Okay, I'm going to come back in here again. Now I just want to have a look at how, so that's how we integrate GraphQL and Neo4j. And so if you want to try that, Neo4j, the library is on here. So you can grab this one on where's it gone? So you can grab this one on npm. If you do npm install Neo4j GraphQL JS, you'll get that available to you, and you can, if you want to use Neo4j as your backend, it will automatically map the queries for you. Okay, let's come back here again. Okay, so next I want to look at how we integrate React. So this is what our component looks like for the application that we're going to build. So we've got, it's reasonably simple. So we're just going to say I've got a title at the top of the page, and we're going to build in a movie search component and a movie lists component based on what we searched for. We're going to define everything in JSX. And we're using the, in case you're wondering what these weird tag names are, they're all from Semantic UI React library. And it's just listing all the different information about the movie. So we've got the title, the year, the rating, the plot. And then we've got the similar movies down here. These are the components that we've got. So right at the top level, we've got the app. If we come in a bit, we've got the movie search widget sitting at the top. There's then a movie list, and inside the movie list, there are lots of movies. So there's only 4 components to it. Now we're going to look at how Apollo glues us together, glues together with GraphQL. Again, this is not the example that we have here is not super complicated. We import a network interface here, and then we've just got to point it at our GraphQL server. So in this case, it would be a GraphQL, the endpoint that we looked at before that had all the resolving. That would be the endpoint that we would point the Apollo client at. I've excluded authorization in this example, but if you had that, you could put it here as well. Then right next up, we've got to connect React and Apollo. So that's just a wrapper around our component. So this is an example from their documentation. So we're just saying, I'm going to put my Apollo provider around the whole of my React component. And we'll have a look in a minute how that works for our one. Finally, we've got GraphQL to React. And so the way this works is we're using this GraphQL function down here. So we just wrap a query around our component, and in this case, it's a to-do app example. And we're just saying I want to execute this GraphQL query, and then it will automatically be binding the results back to whatever we put in here, which in this case is to-do app. So that will come back in. The result of running that GraphQL query comes back in up here, and then we can render the to-do widget appropriately. So I'm going to we'll have a quick look how that works with our movie code sandbox here. So I've got, that should be over here. So we've got, this is the top level, so you can see, I'm just going to zoom it in a bit, hang on. Oh, maybe too much. So this is the Apollo provider wrapping the whole thing. So this just gives us access to be able to execute queries with Apollo for the whole application. And then this is the link to the GraphQL server that we created before. So this is a hosted thing. But if you were hosting the GraphQL server internally, you could obviously just change that URI to be one of your internal URIs instead. And then I've got an in-memory cache so that it can cache results and not have to execute the query every time. If we zoom in on the components, we've got the movie search one, so that's this one here. So we're just executing a search term against it. But the really interesting one is here. So this is where we map the GraphQL query. So this is the GraphQL query. It then goes to that GraphQL server, translates it to Cypher, gets the results back, and puts it onto the component. And so you can see roughly what we're doing here. So we're just saying I want to call. So this is actually using the one that doesn't use the automatic mapping. So we're saying I want to do a movie list query. I want to pass in this title, and then that's going to go and look up movies based on that title and get me 10 of them. And if I change, so I could choose to change it here. I could say, hey, get me the matrix instead. And this will go and execute the query against the GraphQL backend, and it populates it in here. If we decided, what would be a good thing? We could say, let's put in the rating of the similar ones, maybe. We could go and edit our, no, maybe not rating. Can't remember what it is. I don't think we get the autocomplete in here. This might be stars or something. No, I'm not sure what exactly it is. Do we have it on here? Oh, IMDb rating. Okay, hang on. I'll just put that in. So we could put that in our similar section. And if we wanted to then go and change how it gets rendered, if we go in here, we could go into our, where is it? We want that in our, is that in our similar one? Is that where I put it? Yeah, so I've got it in the similar. So we go into our similar section, which is here. And then we could add in movie.imdb rating. So you see we now get the IMDb rating next to it. So it's really easy, like to, if you want to quickly prototype something, this is a very, very easy way of doing it. And we've just changed one record, and it's gone and updated the resolution. It's got a query back. We can go and change it in our UI, and it took about a minute typing one-handed. So imagine if you had both hands, how quickly you could have done it. So yeah, so that, I don't think there's any, there's much more to this to show you. This is a fairly standard React application. I swear I didn't move. But yeah, so there's not really much more to it. I think we're roughly following the React patterns on here. So I am pretty much done. I don't know whether I'm probably a bit quicker than I was meant to be. But I'll give you like a cool, was it Looney Tunes, isn't it? But if you get a chance, if you think this is interesting enough to try out, again, this is where the NPM library is, and if you need any help with it, we have Slack seems to be the way that all dev communities have to help people nowadays. So we have a lot of people on here, Neo4j.com/Slack, and then we have a GraphQL channel on there. Or if you can't be bothered to sign up for yet another Slack, you can always email us here. Otherwise, thank you.